Hello guys, welcome to Ramta Solutions. Welcome to your grade 11 financial mathematics or financial maths. So today on the second video, we're looking at timelines. Okay, we're looking at timelines. So by now you have seen that we've been making one investment into or during an investment period. Now with timelines, we are trying to accommodate what we need to do or how we calculate the accumulated amount at the end of the investment period when more than one payment is made or when withdrawals are made. And not only these, even when interest rate has changed along the way. Okay, so timelines will be assisting us in doing these. Okay, timelines will be assisting us in addressing this situation where there are, we're going to call these things here disturbances. What are disturbances? Payments, deposits, and withdrawals. And another disturbance could be the change in the interest rate. Okay, we're going to come back to this later. Let's address something before we come back to this guy. Now, sometimes your interest, so far when you have been looking at your interest rate, we have been saying it is whatever percent per annum. Now we are going to look at it when, now we're going to say, now imagine interest, now interest is compounded more than once a year. Now interest is compounded more than once a year. I'm going to say compounded is compounded other than a year. Okay, other than a year. I'm using the word compounded carefully, guys, okay? Because normally you will see it whatever percent per annum compounded, blah, blah. So I'm using it carefully, okay? I'm using it carefully, but I'm trying to say this is when now interest will be calculated or quoted more than once a year, okay? It'll be quoted more than once a year. Okay, it will be quoted, interest is quoted other than a year. Okay, it's fine. Other than a year, sorry, or more than a year. Okay, so not more than, other than a year. So far you've been seeing per annum. Now we are going interest rate at let's say X percent per annum compounded. Okay, compounded, because I do not know this value, compounded whatever. Okay, I'm going to call it Y. Okay, compounded Y times. Let me say compounded Y times. Okay, this is what you are going to see. So when interest is quoted more than once a year, that formula that you know is now changing. It's going to be A into P into 1 plus I over F close to the power N times F. Okay, everything that you've been using so far is still the same. This is because it's interest, it's the accumulated amount, principal, interest rate, number of years. Now what is this F? This F is the number of times interest is calculated or number of times interest is quoted. Okay, number of times interest is quoted. Okay, number of times that the interest is quoted. Okay, now I'm going to give you a list of these guys. Okay, I'm going to give you a list of these guys. So I'm going to say compounded. So this is going to be a table that you may need. Compounded, I'm going to use ellipses because something has to follow. And what is the meaning of it? Okay, and what is the meaning of it? Okay, and what is the meaning of it? So when they say compounded half yearly or biannually, okay, half yearly or semi-annually, it doesn't matter, half yearly or semi-annually. What does it mean? Half yearly. How many half years do we have in a year? When you divide your year in half, it has 2 parts. So this means there are 2 equal parts. And then there's going to be quarterly. This one is simply quarterly. How many quarters are there in a year? Guys, you are still in high school. You go to school in 4 quarters. You have 4 breaks, right? You have 4 breaks. So what is this? It's 4. Meaning of quarterly is 4. Then we move to, let's say, monthly. Let's move to monthly. How many months do we have in a year? We have 12. Then we move to weekly. How many weeks do we have in a year? 52. We then move to daily. How many days do we have? This is for a normal year, not a leap year. It'll be 365. Okay, it'll be 365. Please, let's not stress ourselves by saying it's hourly or per minute. Okay, let's not do that. This is an example. I believe this example is sufficient, right? Rather, this list, I believe it's sufficient, right? So I'm going to give you an example now. So example, I'm going to say, let's call him Tiens. Tiens invests 2,500. Yeah, 2,500 rand. Okay, he invests 2,500 rand into an account. Okay, into an account that pays interest rate of 13.5% per annum, compounded. You see now, compounded. When I say quarterly, compounded quarterly. How much will he have after 2 years? How much will Tiens have? How much will he have after 2 years? Okay. So, Tiens, let's see. You invested 2,500. The interest is 13.5%. So we can call it, we can basically call it 0.135. And the frequency with which this is calculated is per quarter. So it's 4 because it's quarterly. The number of years is 2. And obviously we're looking for the accumulated amount. So the accumulated amount is this guy into 1 plus I over F to the power N times F. Guys, even if you write your normal 1 plus I, it doesn't matter. Okay, even if you write your normal 1 plus I close to the power N, it doesn't matter. It's still okay. All right, let's see now. We have 2,500, okay, plus, open bracket, 1 plus 0.135 over 4 close to the power 2 times 4. Now, I want to show you this. Remember, this is compounded quarterly. Now we have 2 years. The question I should ask is this: how many quarters are in 2 years? A year has 4 quarters. So it means in 2 years you will have 8 quarters. So here is it. 2 times 8 is 8 quarters. Okay, perfect. Let's get our answer. 2,500, open bracket 1 plus 0.135 over 4 close to the power 8. What do we get? So Tiens, after 2 years, you will get 3,000, or you will have 3,260 rands and 35 cents. This is the value of your investment after 2 years. Remember, guys, I am saying this formula, it's also okay to write it as this, okay? To write it as this, But note these frequencies. Okay, note these frequencies, or the number of times that your interest is quoted. Please note them. They are very important. Okay. Now, let's look at timelines. Let's now look at timelines. Now, with timelines, we're going to show you this. Understand the situation, okay? So I'm going to give you an example here. I'm going to say, let's say, example, P1 was invested at the opening of the account, Okay, P1 was invested at the opening of the account. 2 years later, P2 was deposited. All right? 2 years later, let me fix this. 2 years later, P2 was deposited. Okay? And then I'm going to say, let me say 3 in fact. So 3 years after P2, so 3 years after P2, 3 years after P2, P3 was withdrawn, right? Was withdrawn. The interest rate was I1 for the first 4 years. Okay, let me just write them like this. For the first 4 years, then I2 for the next 3 years. For the next 3 years. Okay, for the next 3 years. How much would we have at the end? How much would we have at the end? So you see, this is just a general example, but it is exactly what you are going to do in your calculations. Okay, so in our first our solution. First thing first, you draw a timeline, or is it? You draw a timeline, but there you go. And this is time 1, pedi, taro, sino, tataru, supa. Okay, super. So let's say this is T0, T1, T2, T3, T4, T5, T6, T7. This is what I figured. I figured that thing is T7. So now let's read the statement. P1 was invested at the opening of the account. This is at T0. Where is it? T0. So what do? We say plus P1. Okay. And then 2 years later, P2 was deposited. Check this, guys. Check this. This is, hear me out. This is the beginning of the first year. This is the end of the first year. You can also call it the beginning of the second year. Hear me out. The beginning of the first year, beginning of the second year, beginning of the third, beginning of the fourth, beginning of the fifth, beginning of the sixth, beginning of the seventh, beginning of the eighth. You can interpret it like that. Again, this is the start of the first year. This is the end of the first year. The end of the second year, the end of the third year, end of the fourth year, end of the fifth year, end of the sixth year, end of the seventh year. Okay, Cool. Now, 2 years later, P2 was deposited. 2 years later, this is year 1, year 2. So P2 is deposited. As you can see, there's a plus. Now, 3 years after P2, P3 was withdrawn. 3 years after, is it 3? 3 years after P2, P3 was withdrawn. This is 1, 2, 3. So here is it, isn't it? Here is it. This is P3. It was withdrawn. Okay. Now, the interest rate was I1 for the first 4 years. Ooh, for the first 4 years. So this means at T4, we must have those broken lines. Okay. Now you can join this and say, bah. So what is happening? Here you have I1 and here you possibly have I2. Now, this investment ends at T7. So I don't even have to stress. It ends at T7, right? Now, the question is, how much would we have at the end? So, guys, pay attention now. This is what we are going to do now. First thing first, you will say A equals T into 1 plus I to the N. This is the general formula. Okay, now take the equation or take the situation that you have in front of you. So we have P1, it was a deposit. Even if I don't write the coefficient positive, it's fine. P1, it was a deposit. It gained interest I1 for how many years? Let's count. 1, 2, 3, 4. As you can see, for 4 years. It gained another interest, right? Which is what interest? Interest rate was I2 for how many years? 1, 2, 3. Now, when you add the powers, it'll tell you that indeed what you're doing is correct. So P1 was made at T0. I do expect it to have at least power 7 in some way. So look at it. If there was no disturbance, indeed it was going to be 7 because it's 1, 2, 3, 4, 5, 6, 7. Now when you look at the powers, it's 7. I'm okay with it. Okay. Again, that was P2. I'm going to add, because it was a deposit, I'm going to add plus P2. And then first part of it at I sub 1 is for how many years? 1, 2. So here is it, 2. Okay. And then it also gained interest for how many years? Which interest? The interest rate of I2 for how many years? 1, 2, 3. Happy? Now check. If there was no disturbance of the interest rate, it was going to be to which power? 1, 2, 3, 4, 5. Indeed, when you add 2 plus 3, you do find that it is 5. We are good. Finally, we have P3. It is a withdrawal, so I'm going to put a minus. P3, it gained interest I2, so it's 1 plus I2. So now let's look until the last year. It will be 1, 2. You see? So this is how you can do this. You can answer this number line problem. Okay, this is how you can answer this number line problem. Okay, guys, this is how you are going to do it. Remember, you can have more than 2 deposits, you can have more than 2 withdrawals, and you can also have more than 2 interest rate changes. Right? All right. As long as you remember that I said to you right now, your interest rate, you must be careful when you get to it because it is quoted more than once a year. So you need to be careful, okay? Though you wrote this formula, but remember, you need to imagine it like this. Okay? Perfect. Let's go now. Let's see an example to conclude this. Let's see now. An example. So, example. Did we say, okay, example 2. Let's just call it example 2 because we did say example. So example 2, we're going to say Nhlanhla. So this is Nhlanhla. Nhlanhla made an initial deposit. Nhlanhla made an initial deposit of 20,000 rands. Ooh, no. of 20,000 rand into an investment account, that paid, this thing of the strokes annoys me, that paid interest at the rate of 7.2%, 7.2% annum compounded quarterly. Okay, compounded quarterly. After 2 years, the interest rate changed to, let's see, it changed to 7.8% per annum compounded monthly. Oh, the stroke again. Hi. Compounded monthly. Compounded monthly. Now, 4 years after initial deposit, 4 years after the initial deposit, 4 years after the initial deposit. By the way, guys, even in your exam, you will find it this long. After your initial deposit, sorry, sisi. Who withdrew 2,500. Withdrew 2,500 from the investment. From this investment. Okay. From this investment. How much will she have after 7 years? How much will she have after 7 years? Okay. How much will she have after 7 years? So now let's draw our timeline. Solution. Hello, Ntlanhla. T naught moja mbili tatu. What is 5? I forgot. Okay, 5 tisa saba. I think so. In Swahili. Yes. I hope so. Moja mbili tatu nne tanu. I think it's tanu. Tanu sita saba. Yes. Oh boy. I'm ready to go to Tanzania or Kenya. I'm ready, guys. Okay, I'm ready to go there. All right, let's see now. So for 7 years, let's go back. Ntlanhla deposited 20,000 into an investment account. 20,000 Ntlanhla. Is it 20,000? So this is plus 20,000. Okay. Into an investment account that pay interest rate of 7.2% per annum compounded quarterly. So this is 7.2% divided by 4. Okay. Quarterly. After 2 years, the interest rate was changed. After 2 years, so here is it. It was changed to 7.8%. Okay, monthly 7.8. 7.8% per month. Okay. Now, 4 years after the initial deposit, Nhlanhla withdrew 2,500. Did I say 25,000? Oh, yeah, it's 2,500. But I see here I wrote 25,000, 2,500. So she withdrew 2,500 4 years after that. So here is it. She withdrew 2,500. Okay. Now, how much does she have at the end? So A equals P into 1 plus I to the n. It's important that you write this formula. Okay. Now, let's see the disturbances. The deposit is that of 20,000, right? Instead of 20,000, 1 plus the first interest is 0, is 7.2%. So 7.2% is similar to 0.072. It's per quarter over 4. Now for the first 2 years, what does it mean? For the first 2 years, it will be 2 times 4. Then, obviously, it gains another interest of what? 1 plus 0.078. Remember, 7.8% is similar to 0.078. So 0.078 over 12, right? Over 12 to the power. How many years do we have? It's 5. Let's confirm. 1, 2, 3, 4, 5. Yes, indeed, it's 5. So it's 5 times 12. So in 5 years, how many months do you have? You have 60 months, isn't it? Now, when you look at the number of years only and you combine them, you'll realize that indeed it was made at T naught. So indeed, it is 7 years. So we are okay. There was a withdrawal. I'm not going to be okay. I think I will be able to draw it here. So it is 2,500. 1 plus, again, the interest is 0.078 over 12. Now, how many years are left? 1, 2, 3. So it's 3 times 12, right? It's 3 times 12. So let's calculate this. So this is how you calculate this, guys, okay? So this is 20,000 into 1 plus 0.072 over 12. 0.072 over 12 to the power 8 times y plus 0.078 over 12 to the power 60. Okay, so what is this? So this part here is 30,948,57057. Even if you round it to 2 decimal places, it's okay. Minus, let's see now, 2,500, 1 plus 0.078 over 12 to the power 36. What is this? This is minus 3,156,719,992. Because my calculator is Casio, I'm going to say previous answer minus answer. What are we getting? We are getting 27,000. Let me confirm. Let me see. Okay, just want to make sure, guys, that everything is okay. 20,000 plus this guy. Over. Oh yes, my mistake. I saw it. My mistake here. My mistake here. So this is 34. Alright, this is 34. So now this is 34 because the reason it was 30 whatever is because I had said 12. So this is not 12, it's 4. So this is 34,028,19972. Okay. Okay. Right. Now I can say previous answer minus answer. What are we getting? We are getting our answer to be 30,871 rand and 48 cents. So this is how much Nhlanhla will have. Okay, this is how much Nhlanhla will have. So I hope, guys, you have seen now how to calculate this. Okay, I hope you have seen how to calculate this. Now, let me go back once again. Remember, it's important to know what happened. Oh yes, it's important to know the disturbances involved. Right? Look at this. We had so many disturbances: 2 deposits or 2 investments and 1 withdrawal. And now in the example that we just did, we only had 1 deposit and 1 withdrawal. All right. So guys, pay attention to everything that you have. The number of years at the end must sum whatever that you're seeing here. Remember, when you calculate these, this is a timeline. You say this is 1, 2, 3, 4, 5, 6, 7. Right? And now you look at this one, it'll be 1, 2, 3, 4, 5 in total. As you can see, it's 5. When you look at this one, it'll be 1, 2. Indeed, it is 2. So be careful. Confirm that whatever that you did is making sense. Now, on your calculator, for this example given, on your calculator, pay attention to the number of times that your interest is quoted. You see the mistake we made? We also made a mistake of saying, oh, in my calculator, I pressed 12 and 12 here. It gave me a different answer. So please verify your answers. Make sure that you do the right things. Okay, and again, ensure that the number of years are making sense to you. Okay, so this is how you do timelines, guys. Okay, and you are good on your marks. So with that being said, I was Ed here, and remember to get in touch with us. You can visit our website www.ramtasolutions.co.za. At the top on our website, you will see all these icons. You can select any of them and you will be directed to, for these 3, you will be directed to our social media platforms. And if you would like to get a tutor, you can select these 2. This will take you to WhatsApp, as this will take you to your email app. You can send us an email. And of course, I believe you are watching this video on YouTube. Please subscribe. You may also like and share the video. Remember, when you want a tutor, please guys, may it be your parents that talk to us. Okay? May it be your parents that talk to us. So we can decide at the end of the day how much they need to pay for our services and so on. Okay? But remember, at the end of the day, we are going to make sure that we give you the best tailor-made classes. Okay? But it's important that please, your parents are the ones that are inquiring with regard to. Right. So I believe we have come to the end of our video. And look, all the best. So